Imagine an AI so powerful it can solve problems our current supercomputers can't even touch. Welcome to the mind-bending world of quantum machine learning, where the laws of quantum physics meet the cutting edge of artificial intelligence. And today we're diving into a realm where bits become qubits, superposition reigns supreme, and the future of computing takes a quantum leap. Buckle up, this is going to get weird. Quantum computing. But before we merge quantum with AI, let's answer a crucial question. What exactly is quantum computing, and how does it differ from classical computing? At its core, quantum computing harnesses the bizarre properties of quantum mechanics to process information in ways that defy classical physics. While classical computers use bits, zeros, and ones, quantum computers use qubits, which can exist in multiple states simultaneously thanks to a property called superposition. But that's not all. Qubits can also be entangled, allowing them to share information instantaneously, regardless of distance. This enables quantum computers to perform certain calculations exponentially faster than classical computers. Key quantum computing concepts: superposition, entanglement, quantum gates, quantum algorithms. These properties make quantum computers ideal for tackling problems involving optimization, simulation, and certain types of machine learning. The quantum AI convergence. So how does quantum computing intersect with machine learning? Enter quantum machine learning, QML, a field that aims to harness the power of quantum systems to enhance or replace classical machine learning algorithms. QML promises several potential advantages: faster processing of high-dimensional data, more efficient handling of certain optimization problems, ability to find patterns in data that classical algorithms might miss. One exciting area is quantum neural networks, where quantum circuits replace classical neurons. These networks can potentially process information in ways that are impossible for classical systems. But it's not just about speed. Quantum machine learning algorithms could potentially learn from less data, a holy grail in AI research. Quantum machine learning algorithms. Let's explore some key quantum machine learning algorithms that are pushing the boundaries of what's possible. Quantum support vector machines, QSVM. Faster classification for high-dimensional data. Potential for exponential speedup in certain cases. Quantum principal component analysis, QPCA. Efficiently analyze high-dimensional datasets. Potential for exponential reduction in computational complexity. Quantum approximate optimization algorithm, QAOA. Tackles combinatorial optimization problems. Potential applications in finance, logistics, and drug discovery. Variational quantum eigensolver, VQE. Simulates quantum systems for chemistry and materials science. Could revolutionize drug discovery and materials engineering. These algorithms are just the tip of the iceberg. Researchers are constantly developing new quantum algorithms with the potential to outperform their classical counterparts. Current state of QML. Where does quantum machine learning stand today? Let's look at some recent breakthroughs and challenges. Breakthroughs. Google's demonstration of quantum supremacy in 2019. IBM's 127-qubit processor in 2021. Successful implementation of quantum machine learning algorithms on small-scale quantum computers. Challenges. Quantum decoherence and error correction. Scalability of quantum systems. Limited availability of quantum hardware. Need for new programming paradigms and tools. Despite these challenges, major tech companies and startups are investing heavily in QML research. Companies like IBM, Google, and D-Wave are making quantum computers accessible via cloud platforms, allowing researchers and developers to experiment with QML algorithms. Potential applications. The potential applications of quantum machine learning are vast and could revolutionize multiple industries. Drug discovery. Simulating complex molecular interactions. Potential for faster, more efficient drug development. Financial modeling. Optimizing investment portfolios, improved risk assessment and fraud detection. Climate modeling. More accurate weather predictions. Better understanding of climate change patterns. Cryptography. Breaking current encryption methods. Developing quantum-resistant cryptography. Artificial intelligence. More sophisticated natural language processing. Advanced computer vision and pattern recognition. These applications could lead to breakthroughs that reshape our world in profound ways. The quantum threat. While quantum computing promises incredible advancements, it also poses a significant threat to current encryption methods. This includes the cryptography that secures our digital lives, from online banking to, yes, even cryptocurrencies like Bitcoin. Quantum computers could potentially crack these encryption methods in minutes, rendering our current cybersecurity measures obsolete. Imagine a world where Bitcoin wallets are no longer secure, where encrypted messages can be read like open books. It's a scenario that keeps cryptographers up at night. But don't panic just yet. Researchers are already working on quantum-resistant encryption methods. It's a race against time. Will we develop unbreakable quantum encryption before quantum computers can crack our current systems? The future of chemistry. As we look to the future, what can we expect from quantum machine learning? Quantum classical hybrid systems, combining the strengths of both quantum and classical computing. Potential for near-term practical applications. Quantum-inspired classical algorithms, applying quantum computing concepts to improve classical algorithms. Bridge the gap until full-scale quantum computers are available. Quantum Internet. Secure long-distance quantum communication. Distributed quantum computing and machine learning. Quantum artificial general intelligence. Could quantum computing be the key to AGI? Potential for AI systems that surpass human-level intelligence. The road ahead is filled with both exciting possibilities and significant challenges. As quantum hardware improves and new algorithms are developed, we may be on the brink of a computing revolution that reshapes the landscape of artificial intelligence. Quantum machine learning stands at the crossroads of opportunity and challenge. It promises to revolutionize industries, solve intractable problems, and push the boundaries of AI beyond our wildest dreams. Yet, it also presents risks that we must carefully navigate. As we barrel towards 2030, QML could become the defining technology of our era. It has the potential to cure diseases, combat climate change, and unlock the secrets of the universe. But it could also disrupt our current digital security paradigms, forcing us to rethink how we protect our data and digital assets. What are your thoughts on this quantum future? Are you excited about the possibilities or concerned about the potential risks? We'd love to hear your perspective in the comments below. If you're as fascinated by the future of AI and quantum computing as we are, don't forget to subscribe to the LaLa YouTube channel. We're committed to bringing you the latest insights and developments in the world of AI, quantum computing, and beyond. Hit that subscribe button and the notification bell to stay on the cutting edge of tech. Remember, in the world of quantum machine learning, the future is both thrilling and unpredictable. Stay curious, stay informed, and keep questioning. The quantum revolution is coming, and with LaLa, you'll be ready for it. Thank you for joining me on this quantum journey. Until next time, keep your minds open and your qubits entangled.